Hi. So, in the previous video, we learned what is derivative. Now, we're going to see how to calculate derivative by definition. Well, to some extent, we've already did it, but now let's just do it. Step by step. Okay, so look, we've got function y equals x squared plus 9. Now, what we would like to do is to first find the difference quotient. Then calculate derivative. And then in point 3, find the value of derivative when x is equal to 2. And look, this actually shows, in this last point we see in which situation using Lagrange notation is better. Look, when we want to find a specific value of the derivative at a given point, it's way easier to use Lagrange notation than Leibniz notation. Okay, but let's get to the exercise. So look, what we need to do here is to first we need to find difference quotient for expression for a difference quotient of this function. Okay, difference quotient is given by delta y over delta x, or f of x0 plus delta x minus f of x0 over delta x. Okay, so first let's find those two, and then we will be able to just substitute them into the function. So we've got that f of x0. In order to get that, I just replace x with x0, so it's 4x0 squared plus 9. Then f of x0 plus delta x is what we're going to get if I'm going to replace x with x0 plus delta x. Okay, this one actually we can calculate out quite easily. This will be 4x0 squared plus 8x0 delta x plus delta x 4 delta x squared plus 9. Okay, we can start substituting. So we get over here 4x0 squared plus 8x0 delta x plus 4 delta x squared plus 9. And now we subtract the second expression, so we got minus 4x0 squared minus 9, all divided by delta x. Now we can look for different expressions that will cancel each other out. We see here negative 9 plus 9. We see negative x0 squared, 4x0 squared, positive x0 squared. And then we see that all other expressions have delta x in them, so we can cancel them out. Okay, and out of this, we get that delta y over delta x, so the difference quotient, is equal to 8x0 plus 4 delta x. So now let's get to the point number 2. We need to calculate the derivative. If we want to calculate derivative, we need to find limit with delta x approaching 0 out of delta y over delta x. So we calculate the limit of the expression above. Now, look, we can easily see here that is, if delta x approaches 0, delta x turns into a 0, 4 times 0 just 0. So we get that this is 8x0. But because x0 can be now any number, we just can write it as 8x. And finally, what is the value of derivative if x is equal to 2? Well, we just get that this is 8 times 2, because our function is 8x. It's 60. Okay, now let's try another example. Now let's just say that y is equal to 5x squared minus 4x. And again, we need to find difference quotient, calculate derivative, and find the value of derivative at point 2. Okay, so first we need to find difference quotient. So again, we need to find f of x0 plus delta x minus f of x0 all divided by delta x. Okay, so as before, let's start by calculating f of x0, which is simply 5x0 squared minus 4x0. Then we need to find f of x0 plus delta x, which is equal to 5 times x0 plus delta x, right? But here, all we have to do is to substitute x0 for x everywhere, and now we need to substitute x0 plus delta x for x everywhere. So, minus 4 x0 plus delta x. Okay, so again, we need to calculate this whole thing out. And we get this is 5x0 squared plus 10x0 delta x plus 5 delta x squared minus 4x0 minus 4 delta x. Now we can substitute those into the formula for difference quotient. Okay, this is going to be this is going to be a long one. And we've got that this is 5x0 squared plus 10x0 delta x plus 5 delta x squared minus 4x0 minus 4 delta x. And now we need to subtract this expression. So remember, we put minus in front of the entire expression. So here we will have minus, here we will have plus. So minus 5x0 squared plus 4x0 all divided by delta x. And again, we can now see what's going to cancel each other out with what. And look, I see here plus x0, 4x0, here I see minus 4x0. Here I see minus 5x0 squared. Here I see 5x0 squared. So those cancel each other out. Then, again, we can see that all the remaining expressions are containing delta x. So we can get rid out of those. And as a result, we are obtaining that this is 10x0 plus 5 delta x minus 4. Okay, so point 1 done, we found the difference quotient. So now let's go to point 2 and let's calculate derivative. So we calculate limit with delta x approaching 0 out of delta y delta x. So this is a limit with delta x approaching 0 out of 10x0 plus 5 delta x minus 4. And again, we clearly see that the only expression with delta x is this one. So when this is going to 0, 5 times delta x is also going to be 0. And we've got that this is 0. So we get that this is 10x0 minus 4, or because x can be any number than x minus 4. Okay, and finally, again, we can calculate what is f prime of 2. And f prime of 2, we just need to substitute 2 into this function, so we've got this is 10 times 2 minus 4, which gives us 60. Okay, and look, this is how we calculate a derivative by definition. This is a very lengthy, time-consuming process that we're not going to use in the future. Why? Because we will derive special rules that will allow us to calculate derivatives in a fairly easy way. Doesn't matter, like, well, the more complicated the function, of course, the more complex the process of derivation, so differentiation, but still the rules will make our the rules of differentiation will make our lives way easier. Okay, and look, thus far we've established that a difference quotient is a limit. The derivative is the limit of a difference quotient with delta x approaching 0. So it measures instantaneous rate of growth of a function. Now, this already brings us a lot of information, but a very interesting notion comes about when we look actually at the graphs. And look, in the next video, what we're going to do is we're going to look at the derivative from the graphical perspective, and we will see that actually it can be used as a measure of the slope of the function at a given point. Okay, thank you for your attention and see you in the next video.